Hello everyone, this is Priyadarshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to start the next lecture series on model evaluation in deep learning. The topic for today is performance metrics and classification. So in this video we will see how to evaluate the performance metrics for the classification models using accuracy, precision, recall, log loss and specificity. Let's start learning. Let's understand the problem. So consider a scenario. Imagine an AI system that predicts whether an email system is spam or not. So what are all the user expectations? Yes, that is accurate predictions, fewer wrong classification, trustworthy AI systems. But think that when important emails are marked as spam, users lose confidence in the system. This is where the evaluating model performance is very important to be updated. Let's consider the real world impact. So if the classification prediction is wrong, it may create a serious error or it may be not some serious thing. So for example, consider the same scenario if the important email is missed. So it is a critical issue. What happens here is there is a missed opportunity and also it has delays at works. In the same case, if a spam email is missed, then there is no scams or risk. So if the errors are being predicted, it have different consequences. So we need a better evaluation model to classify this one. Why the performance metrics is needed. So accuracy alone cannot always measure the model quality. Sometimes a model may show high accuracy but still make some important mistakes. So the performance metrics helps us to understand different types of errors. It also improves decision making, build reliable AI systems. So the key challenges here are, one major challenge is that accuracy can be misleading, especially with imbalanced data sets. For example, when you take a cancer data set, 95% non-cancer cases, a model predicting non-cancer always may still achieve higher accuracy. That is why we need better metrics like precision and recall to evaluate. So now let's see the first metrics to evaluate the performance model. That is the accuracy of the model. The first thing is the confusion matrix. So confusion matrix is nothing but it compares the actual value versus the predicted value. Consider a scenario that the same scenario that the email is classified as spam and not predicted as spam. So for positive rate, the spam email is considered to be the positive and the normal email is considered to be the negative case. So in confusion matrix, we have four values. First one is true positive, next one is false negative and false positive and true negative. So what is true positive? The email is actually spam and it is also predicted as spam. The model has also predicted it as spam. So this case is called true positive. So what is true negative? Actually the email is not spam and the prediction of the model is also not spam. So that case is true negative. False negative is nothing but actually the spam email is spam but the model has predicted it as not spam. So this case is considered to be false negative. And false positive is actually the email is not spam but the model has predicted it to be the spam. So this indicates false positive. So these are the four things that has to be taken over in confusion matrix. So this confusion matrix itself is not much more better accuracy model. So we need a better metrics to evaluate this email is spam or not. So here let's see an example data. So here 15 are true positive. That means both the model that has been predicted as spam and actual email spam is 15. The same way the other cases are calculated. So this is how we define a confusion matrix. The next metric is accuracy. So accuracy is nothing but it calculates the proportion of the correct predictions. So the formula to calculate accuracy is true positive plus true negative divided by the entire set in confusion matrix. So this is very simple to calculate, but the thing is it may be misleading for imbalanced data sets. Now let's understand when to use the accuracy metric model. So if we can use this accuracy model for evaluating the metrics when the classes are balanced. We have to avoid when the classes dominates the other one, that is for imbalanced data sets. For example, cancer data set. So for this you have to avoid the accuracy as a metric to evaluate the deep learning model. Thank you.